Good morning. We're going to do a sample problem on the worksheet that's assigned, 10.6.20, worksheet 7, forces and interaction, total force, mass, and acceleration. The first thing we should probably take a look at is this funky thing here is another way to say total or sum of all. It's a Greek letter, and when we use this particular Greek letter, that means sum of all. And since we have the capital F right there, this means sum of all forces. So it's another way of saying total force or net force. There are a few different ways to go through and write down that we were talking about adding up all of the forces. And so when we say total force or net force or sum of all forces, we're adding up all of the forces in a particular direction, either lefty-righty, either the sum of all forces in the x direction or the sum of all forces in the y direction, vertically up and down. It's possible in future courses in your life you'll also add the direction that goes into or out of the page. There are a variety of additional things that we can do with that that I'm not going to approach at this point. But this means the sum of all forces in a particular direction. So this problem, the first, I think, 6 questions, the first 6 questions deal with a setup that looks like this, a block that has a few different forces on it. So if this block is sitting on a table, there's this force, capital F for force, and then there's a little subscript TB. So the TB is force of the table on the block. So if you have an object sitting on a block or sitting on a support, this little box is being pushed up by the surface underneath. There are a variety of names for that. We're not going to go into those names, or a variety of accepted names. But I'm just saying that that's the force of the table on the block, or whatever the support is on the block. Then this force down is the force of the earth on the block. And that force is a gravitational force. So the little g in the upper left there is to say it's a gravitational force that the earth exerts on the block, and that's pulling down. Now, if one of these forces is up and one of these forces is down, we, again, with these things, often assign directions or signs to each direction, and that's really mandatory with forces. If up is positive, then down must be negative. So if we add these forces up, it's possible that in some circumstances, those forces would add to 0, and that's actually what happens with this case. If this box, let's say, weighs 4 newtons, that's about a quarter pound, right? No, not quite, my bad. So if this box weighs 4 newtons, then the gravitational force would be 4 newtons down. The vertical force up would be 4 newtons. Well, if that's positive 4 and that's negative 4, those two forces, the sum of all forces in the y direction would be 0. And that's kind of looking at something like this, where we could say the sum of all forces on the object in the y direction would be, and then I just did some generic things here, force of A on the object, force B on the object, force C on the object. We can add up all of those forces. In the example that we just did up here, that would be the force of the table on the block plus the force of the earth on the block. We add those up. It just so happens that one of them is positive and one of them is negative, so they add to 0. Now, looking at the left and right directions, or the x direction, or the horizontal, again, if there's forces in different directions, we need to make sure, that's when it's critically important, that we assign a direction to be positive and a direction to be negative. In this example, left is positive and right is negative. And to the left, we have this force with a subscript RB and a little note up on top of T. I tried to include what this means over here. So T is for tension, like there's a cable or a rope or a cord of some sort. And then RB is there's a rope on the block. So T is a tension force of a rope on a block. And that should have, there we go. So this is the force of tension of the rope on the block. There's a cord that's pulling it that way. This force now with a little note F up above and a TB there. So that's a frictional force of the table on the block. So as the rope is pulling it this way, the table and the block have a force of friction, and that force is going this way. And then I described the gravitational force and that support force there. A couple of notes: equilibrium. Remember, if the total force is 0, then that means the velocity is constant, and we can flippity-flop that. If the velocity is constant, we know the total force is 0. A couple of assignments ago, we went through and talked about acceleration being the slope of a velocity time graph. That's the change in velocity divided by change in time. These are just review pieces from that. So from that turbine glider or glider turbine lab that we did in Pivot Interactives, we have that the acceleration is the total force on the object divided by the mass of the object. This first row is all saying the same thing, just rearranging it using different ways to write these things down, different notations or different writing methods. A is total force over mass. A is total force over mass. I guess if I'm going to be picky, this would be A is the sum of all forces divided by mass. And then solving for total force, we can just say the total force on an object is, one option is to say it's the sum of all of those forces, just actually literally using this definition of sum of all forces, the force that object A exerts on the object, the force that B exerts on the object, plus the force that C exerts on the object. We can expand this out to be as many forces are acting on that object in that direction. I suppose it would be helpful if in this example, if I made all of these little fields go in the same direction. So I'm going to do that right there. Bada boom. Oops. So all of those are the sum of the forces on the object in the x direction. We can also do that in the y direction. Now, this set of equations here, same thing. They're still solved for total force. So we can find total force on an object in a direction either by doing this in the x plus this in the x plus this in the x, or we can say that the total force on the object is that object's mass times acceleration. And these again should have the little subscript x on there, or it could be subscript y on there. So this is the sum of all forces on the object in the x or y direction equals the mass times the acceleration in the x direction. Another way of writing that same thing, F total equals m times a. So it could be the total force on the object in the y direction equals mass times acceleration in the y direction. Rearranging that same equation, solving for mass, that, or that. So that's me just trying to make this video on what all this stuff means as quick as possible. That's not terribly quick, but it's what I can do right now. So I'm going to make a separate video that goes through and talks about just the examples.